Okay, we're starting here. Put in stuff and we got things. Great explanation. Okay, what's our first step? Drop down the 1, and then multiply the -2 times -1, we get -2. After we're done multiplying, we add -3 and -2 is -5. Then we stopped adding, so now we're going to multiply. -2, -5 is 10. We're done on multiplying, so now we're going to add. -7 and 10 is 3. Then we're going to multiply. -2, -3 is -6. Then we're going to add is 9. Then we're going to multiply is -18. And then we're going to be happy because we got a remainder of 0. Now, all we've done so far is x cubes, correct? So we did an x cubed, we got down to x squared, and then we factored it just like from grade 11 and 10. If we couldn't factor it, we had a trinomial factor or a degree 2 or a quadratic factor, correct? But this one isn't going to be x squared, it's going to be what? X cubed. So we're just actually getting back to the question we just did in the previous one. x4 knocks us down to an x cubed. What do we do when we get an x cubed? Put it in our calculator, get a 0, just like we just did. Right? Or just back to the day before yesterday's stuff. So we have 1x cubed minus 5x squared plus 3x plus 9. And now if I gave you that and said factor it, what would you do? You'd plug it into your y equals. Right? We're just back to the x cubed now. What's the lowest one when you plug that one in? Now, do we actually have to use the lowest one? No. I'm just telling you to use the lowest one so that when we go through it, we're actually going through it in the exact same steps so you can tell where you made your error. Sorry, what did you say? -1?
I think.
And so the factor would be x plus 1. I go down here. That's my factor. I drop the 1. -1 and 1 is -1. Add it. -5 and -1 is -6. Done adding, so I multiply. -1, -6 is 6, so I add. 3 and 6 is 9, so I multiply. -1 and 9 is -9 is 0. Box it. And now this was an x cubed, so this one's going to be 1x squared because you're always taking 1x out, so it drops it by 1. What do I have to do with this now? Factor. Go back to grade 10, right? Just factoring. So now I have x squared minus 6x plus 9. What times what equals 9? What plus what equals -6? -3 and -3. And I can go right to brackets because there's a 1 in front. X minus 3, x minus 3. So I can just write that as x minus 3 squared. Okay, paying close attention. This is the factored form of that, correct? Because it's factors. We agree? If I ask for factored form, you give me the factors. So here, we're going to box this, and we're going to say factored form. So if I ask you to factor, we do this, we stop. But what if I ask you to solve? Yeah. Set them equal to 0, because solve just means variable equals a number of some sort, correct? Like it doesn't matter what unit, what math curriculum we're in. If it says solve, there's a variable somewhere in there, you're telling me what it equals. That's ultimately what that means. So we set each equal to 0 and solve. So we get x plus 2 equals 0. X equals -2. We get x plus 1 equals 0. X equals -1. And then we get x minus 3 equals 0. X equals 3. And we'd say multiplicity 2, because there's 2 there. Can you type back in your X4 graph and look at it? I think I have one more day with my calculator, then I have to upgrade. Oopsies. So press graph. Now, what's the very last number on this equation? 18. So that's my what? My y-intercept. So I know I have a y-intercept at positive 18. So I'm going to go to my window and I'm going to make my y max be at least higher than that. So I'm going to make it be 20. I'm going to make it be 30. See what happens. So now I can see my graph better, correct? Okay. Now you know that we said that 2, -2, -1, and then 3 multiplicity 2 were my x-intercepts, or my solving. When I solved, I'm finding my x-intercepts. Why am I finding my x-intercepts whenever you're solving? Because you just set it equal to 0. What is the variable on this side that you just set equal to 0? Y. And we said y equals 0, you're finding x-intercepts. Do we agree? That's why you're finding x-intercepts when you're setting all your factors equal to 0, because you're setting with individual y's equal to 0. So when I look here, I have one x-intercept at -2. So what's happening is, oh, it's going to fight me. Okay, it used to let me draw on it in the other board, but this one won't. So I'm starting at the top, and then I'm hitting -2, and I'm going straight through it. Do you see how there's a straight line through -2? That means there's one x-intercept there. There's no curve, no nothing. That straight line, there's one x-intercept there. This one here, one x-intercept at -1, straight line through. When you have this is called a point of tangency. Okay? We're going to talk about this in the next lesson as well. This is called a point of tangency, where it touches, it bounces, and it goes up. You talked about this in grade 9 too. You looked at circle geometry, and it touched in one spot. That was a point of tangency. Same thing here. So when it comes down, it bounces, and it goes back up. That's going to have at least 2. It could have 4 x-intercepts there, 6, 8, 10, 12. But what happens if it has more is it actually gets wider because it's going to bounce. So, and I'm going to draw it over here. So if it had like 2, it hits it, and then it's like, wait, there's another one there. And then it bounces it back up, right? So that's where you get that tangent, because there's 2 x-intercepts there. So it comes down, it hits the x-intercept, and it's like, oh, I have 1, I go straight through. But then it's like actually like, wait, no, I don't have 1, I have 2. So it bounces it back up. Because if there's 2, it hits it, and it's like, there's another one, and it sends it backwards. So if there's 4, it's just going to bounce a few times like Tigger. So it's going to hit it. It's going to be like, I want to go back up. No, that's 2. No, it's 3. No, it's 4. And it makes it a bit wider. So if you have like 10 there, it'll just be like almost a wider looking tangent. Okay? Yeah.
Could you, probably a stupid question, but
I like how you preface that. You don't have stupid questions. Let's go.
is there any like, could you give us an example graph so we can see how that looks on the calculator?
Yes. So go to your y equals. Not a stupid question. I will verify that your question is not stupid to yourself. Okay, so you're going to go and put a factor. Go like x plus 1 in brackets. And then go in another bracket, x minus 2 to the 10. I don't even remember what I just told you. What did I tell you?
X plus 1, x minus 2.
Because we can do it in factored form, right? Wow, you can't even read this. What is this garbage? I don't even. I love this board. It's my best friend.
Yeah. Okay.
So is it a bit wider? Yeah, so now take the 10 out and put a 6. And if you ever want to compare, keep the 10 in, put into y2, the one with a 6, and see what happens, right? Then you can actually physically compare two on the same graph. You see how it gets wider or narrower a little bit? And if it's 2, it just bounced because it hit once and bounced right back up. That's deflection. So when there's 3, when there's a multiplicity of 3, put it in with a 3 now. Take out the 10 and put a 3. A little investigation. Take out the 10 and put a 3. You take out the 10 and put a 3, what happened?
Went under.
Yeah, and like, even, or it'll come down or up, doesn't matter, but what happens is it'll come up, and then it's like, oh, it's not 1, there's 2, and then it's like, oh, I'm going to try to curve it, make a tangent, like, oh, crap, there's 3, and then it sends it up. So it does like a point, it's called a point of inflection. So what happens is, on a graph when you have a degree, or a multiplicity of 3, is it's like, oh, I have 1, oh, I have 2, I'm going to send it down. It's like, oh no, actually there's 3, and it sends it back up. So it does that curve. So if you have more than 3, what's going to happen is it's just going to make that curve, like that space in the middle, just longer, just wider, just like the tangent.
So if it's even multiplicity, it sends it in the same direction. And
Yeah.
it's just odd, it keeps going.
Yeah, just like odd graphs do, and even graphs do. Yeah.
So if it's multiplicity where technically each of those are on the same point, why does it appear to be longer if all of the roots are just the same spot?
Because there's more of them there. So it's just, it's like, I'm going up, I'm going down, I'm going up, I'm going down, I'm going up, I'm going down. So it just makes it actually wider. It's like bouncing. It's like, I have 1, I have 2, I have 3, I have 4, I have 5, I have 6, I have 7, I have 8, I have 9, I have 10. So it just stretches it. It's not actually wider, it just stretches the pole. So like there still is only 1 dot at 3. It just stretches the graph piece that's on both sides of it wider. Like it just makes it flatter before it sends it up and down. Just because there's more there. It's like, and it's wider. So it's just stretching those pieces. So it's not actually making it, there are more points in that spot. There's still only 1, it just makes it wider. So that's called a point of inflection, and the other one's called a point of tangency. But we're going to talk about that when we get to the other part too. When we go, because what we're doing right now is I'm giving you an equation and asking you for the factors. I'm giving you an equation and I'm asking you for the X intercepts or the roots or the zeros or solving it. But what we're going to do in the next lesson is I'm going to give you the roots, the X intercepts, the zeros, and I'm going to ask you for the equation, so the reverse. And you did it in quadratics. They would give you the vertex and they give you a coordinate, and then you come up with vertex form. You come up with the equation you did in grade 11. Okay. Until this point, you have always had leading coefficients of 1, and you didn't even know you should have thrown a party, but you should have. Because when you have a leading coefficient of 1, what number are you pulling down every single time? 1. And when you pull a 1 down, ultimately in the end, you're going to get to go do product sum. You can go right to brackets, because your leading coefficient is a 1, isn't it? Great day. Should have known you should have thrown a party, didn't even know. Like you had such joy, didn't even know you had such joy. You didn't even know. But now you do. Because now we have a what in front?
2.
A 2. So ultimately in the end, when I get to that trinomial, that quadratic, it's going to need to do decomp. Because I'm going to have a 2. 2 is going to carry down the first synthetic division. 2 is going to carry down the second synthetic division. Then I'm going to get a 2x squared, and I'm going to have to do decomp. Okay? All right. I want you guys to try this one. So I want you to give me the possible zeros, roots, x-intercepts, and then I want you to factor. And if you want to do consistent, do the lowest x-intercept, so we're all doing the same thing. What are you getting for the first one? X equals? -3. Sorry, I should have said the possible ones, or plus or minus 1, plus or minus 3, plus or minus 9. And Hunter, you said -3?
Yes.
Okay. So we always have to check, can we rocket count? And say you forget that. Say you forget to rocket count. But you get a remainder and it's not 0. Think, what could be happening here? Often if you have looked in your calculator, you've pulled off the right x value, right? It's just the x-intercept. Sometimes people pull off the y-intercept by oopsie, so sometimes that's the error. But most often it's that you didn't check if you could rocket count, and then you missed the placeholder, and then you got it wrong. Okay? This one, 4, 3, 2, 1, blast off, we're good. So we can fill in our numbers, 2, 3, negative 17, negative 27, negative 9. What if it's x to the 5? What's going to happen? Yeah, you're just going to get another synthetic division. Because every synthetic division knocks it down a degree, right? So if you have x5, it'll knock down to x4. x4, it'll knock down to x3. x3, it'll knock down to x2. So you'll do synthetic division 3 times and then factor. Okay. Drop the 2. 2 times negative 3 is negative 6. Add it is negative 3. Multiply is 9. Add it is negative 8. Multiply is 24. Add it is negative 3. Multiply is 9. Add it is 0. We are happy. Now we have 2x cubed minus 3x squared minus 8x minus 3. And what's our next one?
X equals -1.
So now I have 2, negative 3, negative 8, negative 3. 2 times negative 1 is negative 2. Add it is negative 5. Multiply is 5. Add it is negative 3. Multiply is 3. Add it is 0. And now it's squared. 2x squared minus 5x minus 3. And I have to factor that. 2x squared minus 5x minus 3. What times what gets me negative 6? What plus what equals negative 5. Remember, you multiply the outside terms and it adds to the inside. Multiplies the outside, adds to the inside. So what are our two numbers?
6 and positive 1.
Now we can't just go x minus 6 and x plus 1, because that would mean there's x intercept at 6 and negative 1, which there is not. If you go look on your calculator, it doesn't exist there. So you have to decomp whenever you have that coefficient of a 2. So we replace this middle term. So we're going to get 2x squared. And instead of writing 5x, we've decided that, hey, negative 6x plus 1x, that is actually 5x. So I can just take this negative 5x, grab it, and I'm like, see ya, punt it that way. That was not a punt. Throw it that way. And then, this is a punt. Punt it that way. And then I'm going to take this and put it in there. Someone's cheering outside. Negative 6x. Probably because of my punt. It was so good. They just cheered for it. Isn't that so nice? So sweet of them. Okay. Negative 6x plus 1x minus 3. I think Hunter just pity laughed for that one. That's okay.
Tell me to do that.
I will take pity laughs for anything. Over no laughs. Okay. Then we group the first two, we group the back two. What can we take out of the first two? We can take out a 2x. What are we left with? X minus 3. What can we take out of the back bracket? A 1. What are we left with? X minus 3. I have two terms, this one and this one. What can I take out of both of them? I can GCF an x minus 3 to the front. And I'm left with 2x plus 1 after I GCF that. So this is factored. If they ask for the factors, this is it. If they ask you to solve, we've set equal to 0 and solve, right? So x plus 3 equal to 0 is x equals negative 3. This one's going to be positive 3. So they're going to write it as plus or minus 3. And then negative 1. 2x plus 1, what does that become?
Negative 1.
Negative a half. So which is the only one not showing up on your calculator table? The negative a half, unless you made your calculator table be 0.5, change in x that I told you. But you can find these all with your calculator, just not on your table, correct? Now, you can confirm it by saying, okay, there are 4 x intercepts in front of my face, and they're all straight lines. So, and one's going through negative 3, one's going through positive. The catch here is if it says solve algebraically and you take them off your calculator, you're getting 0 marks, just so you know. Okay? Can you grab out a piece of paper? I'm going to give you 2 unique situations. You can insert them in wherever you want, but I want them on a separate sheet of paper and maybe highlighted, because these are the 2 that people forget how to do. Okay? So I can put them in your notes, but then they won't be nearly as like, hello, look at this, you know? So on a separate piece of paper, you're going to put these 2, highlight them. It's a unique situation. I don't really care. They're not hard. They're just forgotten about. You remember them, and then they're easily forgotten. So one of them is this. F of x equals x to the 4 minus 4x cubed plus x squared plus 6x. Now, when you go to list possible zeros, what are your possible zeros? There's just 0. The constant is 0. If you get a constant of 0 and you're sitting there staring and you're like, I don't know what to write. This is awful. This is this moment. Okay? This should be like light bulb. We had this moment in class. It was September 29. It was 9:17. Okay? It was when she said, if the constant is 0, there's nothing you could write. It's plus or minus 0. There's a better way. There's something we have to do. What is that something? What is that something? And then you remember this day. Take out an x. There's no constant. If there's no constant, everything has an x. We can take out an x. Then our next part will have a constant. Boom, boom, boom. Do some math. Get some answers. Be happy. You know? Okay? So when we don't have a constant at the back, that means we don't have a number like 7 or 6. And when we have a number like 7 or 6 or 2 or -2, we can't take a GCF of an x out because that term doesn't have an x. We agree? But when we don't have a constant, our very first step is to get a constant. And how do we do that? We GCF out an x. So we've already found one factor super easy. Like I said, this is actually easier than the other form because I don't have to do synthetic division to knock this down to x cubed. I just take an x out. So I take out an x, and I'm left with x cubed minus 4x squared plus x plus 6. Boom. Easiest way to get it to x cubed ever. But if you forget this little step, you stare at it for forever. And then you get mad and you call me over and you're like, there's nothing. And I'm like, but remember the day, September 30th, 9:17. Yeah? It's the best of times. It was the worst of times. Okay. Now what can we do? Synthetic division. We have one factor. It is x. Don't forget about it. And finish the question. Try it out. I want you to factor and solve. So what's our first number for this one? The 1, -4, 1, and 6. -1? Now, like I said, you can pick positive ones as well. It's just that if we all want to kind of follow the same one and see where we made an error, if we consistently all pick the same thing, then you can catch errors. So we drop the 1. -1 and 1 is -1. Add it is -5. Multiply is 5. Add it is 6. Multiply -6 and 0. So I'm going to go over here and put x plus 1. And then I have x squared minus 5x plus 6. And now you know to actually throw a party because this had a leading coefficient of 1. So we got to do some brackets at the end and not decomp. Although I do love decomp. It's just nicer. You don't have to. Okay. So what multiplies to give me 6 and adds to give me -5? Trick question. How you should get it. It's not -6 and 1. It's -3 and -2. Oh, we have a whole bunch of X intercepts that are just going straight through. I have 4 X intercepts. Is that possible? Yeah, because the graph was an x4. So it maxes out at 4. What does it min out at?
0.
0. Because x4 graphs either look like a really wonky W if they're positive, or an N if they're negative. Because they go in both arrows up or both arrows down, right? So you could have 0, and you max out at 4, and then every varying level between 1, 2, and 3. Okay? So this is factors. So if I ask you to factor, this is the answer. If I ask you to solve, what's my answer? X equals 0.
Negative 3.
And you don't have to say multiplicity 1. You only have to say multiplicities if it's like 2, 3, or 4, or 5. Okay? All right. Does that one ring a bell now? If I don't have a constant, I have to GCF. That's what you immediately have to think, or you will be stuck for life on this question. Okay? The other one, this is the one I want you to do next. Okay? So this is it. It's going to be x squared minus 27x plus 10. That's a lot. X cubed. I was like, that's grade 11. Minus 27x plus 10. I want you to try and factor and solve it. See how you do. There's 2 places, actually 3 places that could get you hung up. That's why I gave you this question. Where's one of the hang-up points could happen? Yeah.
No.
Not rocket counting. So we know we need to have an x cubed plus 0x squared minus 27x plus 10. Where's another hang-up that could happen?
Smallest whole x-intercept is the biggest one.
Yeah, it is 5. There's only one. Now, when you go to look at your graph, so everyone has a typed in press graph. How many times is it across the x-axis? 3, but you're only getting 1. So that means that the other 2 are decimals of some type. They could be a fraction. It could be like the last one was a half or something like that, right? Or they could be crazy decimals, right? But we do know that there are 2 others. Now, do you remember how to find your x-intercepts using your calculator? So when you're stuck on that, you go second trace and then number 2, which is the zeros, and you left bound, right bound, find the x-intercepts, right? So second trace 0, find one of the wonky x-intercepts for me, every single person. Second trace number 2, and then you're going to go left bound on the left of one of them, hit enter, on the right of one of them, hit enter, and then hit enter. And you're going to get an answer. And the answer is?
0.37228132, la da 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 da.
Yeah, if you could dance to it has to use quadratic formula to get the answer. That's what you have to think. If you were head bopping on, you use quadratic formula. If it's like 0.66666, that's a fraction. That can come from decomp, right? If it's x to the half, that's a fraction. That can come from decomp. If it's 0.333333, that's a third. That can come from decomp. If it's like 0.39842777392, I use the quadratic formula. Yes? So you can, finding them using your calculator, that can scream what you should do. I want you to understand when you see answers like that, that's a quadratic formula question. Because they're probably going to want it, and if they say determine in the exact value means not decimals. So they do not want those answers. They want the reduced quadratic formula answers, like we learned last year. Okay? So x equals 5 was my first one. So I have 1, 0, negative 27, and 10. And then x minus 5. So I drop my 1. I get 5 times 1 is 5. Add it is 5. 5 times 5 is 25. Add it is negative 2. 5 times negative 2 is negative 10. And I'm happy because I get a 0. So I have x squared plus 5x minus 2. So for my factored form, I'm going to have x minus 5, and then I'm going to attempt to factor this. So I have x squared plus 5x minus 2. However, I know this isn't going to factor. How do I know it's not going to factor? Because I looked for my x-intercepts. I found that they were the singing ones. So I know I'm going to have to use the quadratic formula, which means I can't factor it, which means I can't factor that anymore, right? So this is a linear factor, the x minus 5, because if I put a y in front of it, it would draw a linear line. And this is a quadratic factor, x squared, or degree 2 factor, plus 5x minus 2. This is literally all they're going to look for if they want factored form. But some of you guys will sit here for life and you're like, that has to break down. It can't. It can't break down. This is when, once again, you should be singing songs of joy because you don't have to factor it. It can't factor, right? So factored form, we would leave it as that trinomial, okay? Because you cannot factor it. There's nothing in the world that multiplies to negative 2 and adds to 5. 2 is 2 and 1 no matter what way I switch that, I ain't getting 5, right? So I cannot factor it. Now, problem with that, though, is sometimes people are like, I can't factor it. They put it down, but they actually messed up, but they don't realize they messed up. They just think you couldn't factor it. But you have knowledge. You have lots of knowledge. So when you found your x-intercepts, you knew they were those singing x-intercepts. So I knew that I'm going to have to use quadratic formula, which means that ain't factoring, right? So when that doesn't factor, I feel confident in myself because I just found some x-intercepts that correlate to a quadratic formula, which means I can't factor. So you should walk away feeling confident about this answer, not like, uh-oh, did I make an oopsie somewhere? Does that make sense? Or did I not figure out a factor and I could have factored? Okay? So if your x-intercepts are like 1, 7, a third, a half, something like that, then you can factor it more. But if they're those crazy decimals, that's quadratic formula. Okay? So factoring, you're done. It's a really easy question if it's factoring. If it's solving, you have to go to the quadratic formula. Which the quadratic formula on your formula sheet, this is yours, is at the very top. And it says it has to be in the form ax squared plus bx plus c equals 0, which means everything has to be set to one side equal to 0, which was embedded in your soul last year, I swear to goodness. So it's set equal to 0. And when you set it equal to 0, this is your a. This is your b. This is your c. Okay? Then we use our quadratic formula, which is x equals negative b, so negative 5 plus or minus the square root of 5 squared minus 4 times 1 times negative 2 all over 2 times 1. So you get x equals negative 5, and then you do everything underneath the square root. So it's going to be 25 plus 8, which is 33 over 2. Can 33 reduce? No, 24 could reduce. It would be 4 and 6, so it would be 2 root 6. 72 could reduce. It would be 36 times 2, so it would be 6 root 2. Remember how we reduced them? Okay, this one can't. Now, please pay attention because some people draw these poorly and then they'll lose marks. The quadratic formula is an entire numerator over an entire denominator. We agree? An entire top over an entire bottom. So please make sure your line shows that. An entire top over an entire bottom. An entire numerator over an entire denominator. Some people have like a 3/4 line. You'll get lost marks because it'll look like negative 5 is sitting alone by itself and only the root 33 is divided by 2. Whether that's what you meant to think for it or not, it'll read that way. So you have to make sure that you have that full line. Now, this is a 3-for-1 deal. It's like the best deal ever. When you're doing the quadratic formula, you have a 3-for-1 deal. It's either 3 or no deal. Deal or no deal, okay? How do I know it's a 3-for-1 deal? Well, you have 3 terms. You have this term here, the negative 5. You have this term here, root 33, and happens to have a 1 in front of it. Do you agree? Do I have to show the 1? No, I'm showing the 1 to show you that that's the 2. That's the second term. And then the 2 is the third term. You agree? So this is term 1. This is term 2. This is term 3. And if I can't get a 3-for-1 deal, I can't reduce this any further. We agree? So I have a negative 5er, a 1er, and a 2er. Can I take anything out of those 3? No. So am I allowed to take anything out of this? No. Do you want to know how great the quadratic formula is done until this point? You guys do like all the hard stuff really awesomely, and then at the end you're like, if it's a 6 and a 2, I get like -3 and 1 all the time. It's a 3-for-1 deal. It has to come out of all three or not at all. So if you were given something like this, x equals 6 plus or minus root 33 over 2, sorry to say, that baby's staying. Because 6 and 2 are 2. And can I do a 2-for-1 deal on a quadratic formula? No. I am cheap. I want a 3-for-1 deal. And I'm not doing anything better than that. You ain't giving me a 2-for-1. Nope. Nothing. So it has to come out of here, here, and here. Is it coming out of those three? No. Then it's coming out of none. Okay? This bad boy is done. That can't get reduced anymore. Do not try and like, oh, that's so sad. Like all this work. And then the thing is, you should catch your error if you reduce it wrong. Because if I put this in as 6 plus root 33 divided by 2 in the fraction button, or if I have the TI trees, I take the top in by itself divided by the bottom, it should match the decimal you got on your calculator, right? If it doesn't match, you may be reduced wrong, because you can find the answers on your calculator. So that has nothing to do with this question, just proving a point. Can't take anything out of any of them, not even a 2-for-1. This thing's done. So if I went and did solving, if I said solve, my answer would be x equals 5, comma, -5 plus or minus root 33 all over 2. Because I feel like you're understanding everything really well, we're going to do one more. One more understanding. Yeah. If I gave you something like this, we're doing one more, but I'm giving you a little caveat in the middle here. If we did something like this, that is a degree 3 function. That is a cubic function. That is an x cubed function. That's a function, right? This has one x intercept, and then this results in no x intercepts. What is that going to look like when you're solving? When you factor, you're going to get a linear factor and then a quadratic factor, right? That's what's going to happen. But when you solve this, what's going to happen? Your discriminant is what? Negative. So this here will get you an answer. What the heck is the discriminant? The discriminant is the thing underneath your square root symbol in your quadratic formula. Remember last year you did the b squared minus 4ac thing? It's called your discriminant. I'm just showing it to you. And we said when this bad boy here when this was greater than 0, what's underneath here, I got two solutions, correct? When it was greater than 0, if I have 33, I'm going to add root 33, I'm going to subtract root 33. I'm going to get two solutions. Then we said when it was equal to 0, we actually got one solution. Because if I added 0, root 0, and subtracted root 0, I get the same answer. But then there was the case where if it was less than 0, we actually got no solutions, because you can't take the square root of an negative. I just moved too fast in front of it. I have no idea what is going on. Didn't even know it could do this. Okay, keeps me guessing, on my toes, really. When it's negative, you can't take the square root of a negative number, right? So the cool thing is, when you ever get a graph like this will get you your first solution. But with the other one, when you put in the quadratic formula, you're going to get a negative under your square root, which is going to mean no solution. And therefore, it's going to prove that you really only have one. Because they're going to ask you to solve algebraically, right? Solving algebraically, you'll put your first one in, you'll do your synthetic division, you'll get an x squared. And how do you solve algebraically? You take that x squared, you put it in your quadratic formula. When you put in your quadratic formula, you're going to get a negative under the square root, or there's negative discriminant, which says there's no solution, proving that there's only one. And you're not freaking out because you've put it in your calculator and you see there's only one x-intercept, right? So when you get the quadratic formula with a negative underneath, it should be like reassuring, like a nice warm hug, really. Like, look at you, you did so good. It matches. Yay. Okay? Cool. All right, I'm going to have you do one more on your own. And then you have no homework because we've done all the homework on the board. You just didn't know it. Here it is. I gave you all the hard ones. I'm going to use a Q because it is a Q. Enjoy. Q4 plus 2Q cubed. That's not a tongue twister. 2Q cubed. Plus 2Q squared. Sounds like I said squared, but not squared. There's a lot of 2's in this. Minus 2Q. Minus 3. I want you to factor and solve. Make sure you're using Q's. I caught myself using X's. So that would be factored form because I can't factor that. And then I'm going to check this quadratic formula for solving. So that's my A, my B, my C. X equals -2 plus or minus the square root of 2 squared minus 4 times 1 times 3 all over 2 times 1. -2 plus or minus -8 over 2. Once you get -8, you know there's no solution. And then before you freak out or feel super confident, because you might be feeling overconfident and be wrong, how many x-intercepts should there be when you type the original into your calculator? 2. How many are there? 2. So should you feel confident at this point? Yes. Okay. So always go back and check. I have an X again. It's an X addiction. That's what I have. I'm going to put Q's here. Okay. So we're going to have, for when it says solve, your solutions are just going to be Q equals -1, and I guess plus or minus 1. That's it. You don't actually have to write anything about that. That just shows that you algebraically solved it.
So even though that isn't a solution, you keep it in the factored form.
Yes. Because factored form is just another way of showing the graph, the exact same graph. So if I pulled this off of here, it would just give me a quadratic graph. So factored form is just another way of showing the equation in factored form. So the equation itself is in standard form originally. Now it's in factored form. So if I pull this off, I won't see the graph. Now when you want to check factored form, you can easily check your factored form equations, right? You put your original in y1, you put your factored form in y2 with that thicker line, or if you have colored lines, you have to do that, and it should draw on top of it. If it doesn't, your factored form is wrong, because it's just another way of representing the exact same equation. But solving tells us the x-intercept, so we don't have to show that other piece. Does that make sense?
Yep.